In this video, we're going to examine some properties that are related to ionic bonds. So we started by talking about ionic bonds, and we know that an ionic bond is when a metal transfers its valence electron to a nonmetal, forming ions that are attracted to one another. So in this example that we have been talking about, you know that sodium is going to transfer its valence electrons to chlorine, ultimately producing a positive 1 charge. Chlorine is gaining 1 electron, so it is going to have a negative 1 charge. These two particles, because they're oppositely charged, they're going to be attracted to one another, and that attraction is called an electrostatic attraction. So in this video, we're not really going to talk about how ionic bonds form, but what we're going to talk about is these physical properties that affect the ionic substance once the ionic bond is already formed. The good thing is that most physical properties are only affected by one thing, and that one thing is the strength of the attraction between the particles. So we know that these ions are attracted to each other by their electrostatic attraction, but we don't know is how strong is this attraction, how strong is that aka ionic bond. Another thing that we need to talk about is the actual particles themselves. You need to be able to understand what particles are involved in ionic bonding and be able to talk about them in the correct way. So let's start talking about the particles that are involved in an ionic bond. So here we have an example of sodium chloride, which is commonly known as table salt, and that involves this ion sodium and the ion chlorine. So one thing that ionic bonds are not, they are not molecules. Most people think that when you have an ionic bond, you have a sodium particle and a chlorine particle, and they join together to become molecules, and then you have so many of these molecules. This is not correct. Ionic bonds do not have molecules. So what that means is individual sodium chloride molecules don't exist. So if they're not molecules, then what are they? These particles that are involved in your ionic substances, they're actually ions. So you have a positive 1 sodium ion, and that's going to be attracted to a negative chlorine ion, and then that negative one is going to be attracted to another positive sodium until you just have multiple attractions of ions that are attracted to one another. Then what can happen is you can have like a 3D structure where more particles or ions are attracted to one another, and then eventually this entire ionic bonding of these substances are going to form like a 3D structure of actual sodium that you can see. Right? So that's our first key idea, that our ionic compounds, they're basically just organized in rows of ions. They're not molecules. And what we refer this structure as, these organized rows, we call them a lattice structure. And here's a picture of an actual lattice structure. So remember, ionic compounds are not organized rows of molecules, they're actually just ions. So I know that we talked about that most physical properties are only affected by one thing, and that's the strength of the attraction between the particles, which is that ionic bond. And the good thing to remember is that ionic bond is super strong. It's very strong, and it's really hard to break away these two ions. So that is our next key idea. These ionic bonds are really strong, and what that does is, because they're so strong, they keep the ions very tightly in place together, and it's very difficult to separate them. Because of these ionic bonds and how strong they are, they like to keep ions really tightly in place. So think about the 3 states of matter: a solid, liquid, and gas. So this property of ionic bonds can relate to some physical properties for ionic substances. Because they like to keep these ions very tightly in place because this bond is so strong, the first property is that ionic compounds, they tend to always be solid at room temperature because it's really hard to break away these two ions once they are attracted by the ionic bond. The second property is, because these ionic bonds are really difficult to separate, the second property says that you need a lot of heat to actually take these solid substances and turn them into the liquid form. Therefore, ionic substances always have a very high melting point, which means that it takes a lot of heat to melt these different ionic bonds, ionic substances. Another property that relates to ionic substances is that ionic substances can dissolve in water, all right? So this is an animation of our sodium chloride ions, and you can see that a water molecule is coming together and actually pulling these ions away. So they are very strong and held tightly in place in the solid form, but once water comes into play and you start dissolving these ionic substances, they will dissolve in water. Another thing to consider is that, remember, the ions in a solid, liquid, or gas, they can't really move when they're in the solid form. They just kind of vibrate back and forth. But when you take these ions and they're either melted or dissolved in water, they can move around. So you can see they're a little bit more free to move around. So that leads into our next property. Our next property says that when in the solid form, ionic substances cannot conduct electricity because they're not really moving. Ions need to move in order for the electricity to kind of flow, right? But when these ionic substances are molten or dissolved, they will conduct electricity because they have some free space to move around, and those charges can allow electricity to pass through. And that concludes our video. So here's a quick recap of all the different key points that we talked about in this video. Thank you for watching.